Okay, gents, we're working on this SP220, and like I said in the previous segment, we're going to flip it over and check for filament and bias switch, or what they call bias flop. Now, I'm going to break this out in its own separate video for everybody to watch, even though I've shown this like 100 times on YouTube on video, but I've never done its own independent video on how to check this voltage. So when I say, well, I showed it on video, everybody's like, well, where's the link? I've never done a specific video just for this. I didn't think I'd had to, but there's 3 or 4 guys that I'm working with right now, this minute, and I keep telling them there's something wrong with their bias. And they're like, no, I don't get it. I don't understand what you're talking about. Okay, so we're going to explain it. So right now, we've got our probe set on AC. Your tube works on 2 separate principles. AC for the filament, but DC voltage for the bias. So let's go ahead and bring our filament on. So we brought the amp on, and for SP3500Z, you're looking at roughly about 5 volts, 5.5 volts in the filament. So we're going to look at that on AC, on this lead and the other lead. Now I can tell you right now there's nothing wrong with this filament transformer. Okay? Now how do we check for our bias? Well, let's turn our amplifier off so we don't get ourselves electrocuted. We're going to disconnect our positive lead and disconnect our negative. We're going to take our negative and we're going to hook it up to the case. We're going to take our positive, and it doesn't matter if the positive's on the front or on the back, we're going to leave this hooked up to the back. Okay? So now what we're going to do is we'll turn the amplifier back on, but first we got to turn our voltmeter to DC. So now we're reading DC current, or DC volts, from case to the filament leg. As we can see, we've got 126.8 volts worth of DC voltage that's present. Once again, it doesn't matter which leg you probe this on. You have 126 volts DC that's present. On the AC side, you're going to have half the voltage before, because you're only reading half the transformer. But you need to look on the DC side. This 128, 29, 130, I've seen them as high as 135. That voltage will stop your tube from doing anything. It's called cutoff voltage. If you have this voltage applied to the tube and you step on the foot pedal and your relay clacks down, let's say like your bias zener goes out. That's the diode that's up on behind the high voltage board. If your bias zener goes out, you're not going to get any bias flop. Now what do I mean by bias flop? We've hooked up ground here, and now watch what happens. I step on the pedal, and now our voltage drops to 3.37 volts. It'd actually be a little bit higher with the tube in the socket, but check. So that DC voltage, we're now removing it from the tube, and we're allowing the RF electron pixies to go into the tube, and the tube can now amplify. If you don't have this voltage drop when you step on the pedal, that tube will not do anything. But that is how you probe for bias flop. You must have a positive 100 and plus 20 volts for cutoff to shut the amp off when you're not on the key. And then when you step on the pedal, you must have that on a switched circuit. Must have that on a switched circuit so it drops to 3.5, 4 volts. 5 volts is even acceptable, but not much more than that. And this voltage drop is all determined by the diodes that are in the string. Now if you go to the Harbach board, let's say you have the Harbach high voltage replacement board, you're going to be closer to the 5 volt range, which is fine. You don't want to go much past like 5.5 volts though. The tube's going to not react very well, which is kind of cool. You could put a variable resistor in line with the center tap of the transformer, and you can actually dial the reactance of the tube up and down. But you get too far out of that and it starts screwing with the class operations of the tube, so don't do that. It's an old Seabeer trick, don't do it. But that's what we're looking for, is we're wanting to make sure that when we step on the foot pedal, the center tap of the transformer gets engaged up to the zener. The zener is going to drop to your 3 volts. If you see that 3 volts, it's not a bias issue, then now it becomes an input issue. Is the RF making it from the coax connector at the back, through the input circuit, and then to the tubes? That's how you check for your bias. Very simple. Okay. Shut this down up here on the front. And I know for a fact that this amp is going to work now that we've fixed the high voltage, fixed the filtering bank, fixed this breaker, and fixed the keying circuit. Got all the bugs worked out of it now. Let me jump back in here and say that there's a couple other technical things that we have to discuss. So you have your filament transformer, which has got your one leg and then your other leg, the 2.5 and 2.5 volts. Well, there's actually 3 legs on that filament transformer. You've got your 2.5, your 2.5, and then your 0 center tap. So you have your anode, which is the upper portion of this tube structure, and then you have your cathode, which is at the bottom side of the tube and on the inside. The only way you can have access to the cathode to do anything inside the tube or control the tube is through that center tap on the filament transformer, that center leg. So you will notice on the SB220 that there's a black wire that comes up from the corner of the cabinet by the filament transformer. So front of the amp, filament transformer, you have a black wire that comes up and goes to the center of the board. Well, off of that center transformer, the board, you've got behind the high voltage board, you've got that zener. Well, that zener is what creates that voltage, the DC voltage. So when you step on the foot pedal, click, the relay on the bottom takes the lead that comes off the high voltage board and it runs down and it goes to the relay. It takes the cutoff voltage, which is the 125 volts, click, and it switches to that zener. And that zener is what makes that control voltage be present. And that allows the tube to turn on and start amplifying. If the zener goes bad, which they're very hard to find, at least they were for a hot minute. I haven't gone out to look to see if there's a plethora of them around, but sometimes those zeners, I've seen them as high as 75 bucks. I've seen them as high as $5. But then again, that's Chinesium, don't know what it is really. Zener. It's usually cheaper just to buy the Harbach high voltage rectifier board. The Harbach high voltage rectifier board's got a string of diodes in it. I think a total of 4 that it uses for bias control. Okay, and it's the same principle. The center tap of the filament, which allows us to have access to the cathode. Now we're taking the cathode to ground through those diodes and we're creating that voltage, which is allowing the tube to turn on and say, okay, go. You cannot take it to 0, like 0 volts, the tube will run away. So if you fart on it, the tube will run away and just oscillate. So we have to have a little bit of control voltage, that 5 volts, 3 to 5 volts worth of range that we have to have as a control voltage to keep the tube on, but not doing anything crazy. And then as soon as we come off the key, we want to shut the tube completely off, and no matter what goes on around the tube, you have 100% control of the tube. That's the reason that we take it to the 125 volts. We totally overwhelm the cathode with signal to the point where there's no room left. And this is just dumb. This isn't actual per technical term. I'm making this in normal human speak. We're filling the cathode of the tube up with signal, a different voltage that shuts the tube off and doesn't allow it to do anything. So it shuts the tube down. So the tube goes, ugh. It's like having a gas pedal in your car. 3.5 volts, tube's ready to go, rock and roll. You go all the way to the floor, the motor's going to blow up. The tube will blow up. But if you come up just a little bit, that's how you maintain your class of operation of AB1. You come up off the floor about 1 or 2% off the floor, off of full throttle, the tube's ready to go. And so whatever you put into it for signal, the tube will amplify it. But when you come off the pedal, like in the car goes back to idle. It's the same thing that's happening with the tube with the 125 volts. And that's the whole point behind this test. Because those zeners do go bad for a lot of myriad of different reasons. If you have a high volt short in your box that somehow is present in your tube, it'll zip from the anode through the cathode, back through the filament leads and wipe out that zener on the center tap of the filament transformer. Well, okay. I had the thing blow up, so I went in and I replaced my parasitics and I replaced my plate choke, and I put new tubes in it, and it still won't do anything. It's because that zener took the brunt of the high voltage shock and it got wiped out. So you got to replace that zener, otherwise you have no throttle control of the vehicle or the tube. That's the easiest way I can explain it to you without it being a giant technical, long, drawn out, using big words where somebody's got to go get a Google thesaurus to figure out what the hell I just said. So, there you go. Hopefully this helps somebody out there understand how to diagnose what's going on with their SB220. And if you've liked this video, this little short clip on how to fix your bias, or any of the other videos I've done, make sure to hit subscribe. Give me a little thumbs up. It helps with the YouTube algorithm. And really, if there's anything I can do to help you, don't hesitate to come over and join us at patreon.com. BBIAM's patreon.com. Only costs $1, and just a little bit of help goes a long ways over here for me, and it allows me to be able to show that you're supporting us. Thanks, gentlemen. Got more to go. We'll see you. Bye-bye.